Welcome back to Arxflix. Today, we're diving into a comprehensive paper titled Scaling Language Models: Methods, Analysis, and Insights from Training Gopher. This research provides an in-depth analysis of transformer-based language model performance across various scales, from tens of millions of parameters all the way up to a massive 280 billion parameter model called Gopher. Let's break it down. The Gopher model is the centerpiece of this research. With 280 billion parameters, it represents a significant leap in scale compared to previous models like GPT-3. Gopher was evaluated on 152 diverse tasks, achieving state-of-the-art performance on most of them. But what makes it so remarkable? Here, you can see an overview of the performance improvements Gopher achieved compared to other state-of-the-art language models. Notice how Gopher significantly outperforms previous models across a broad range of tasks. Let's go over some of the key findings from the paper. Gopher showed the largest improvements in areas like reading comprehension, fact-checking, and toxic language identification. However, its performance gains were less pronounced in logical and mathematical reasoning. The researchers scaled 6 different transformer language models, ranging from 44 million to 280 billion parameters. They used an autoregressive transformer architecture with some tweaks like R's norm and relative positional encoding. All models were trained on a dataset called massive text, which includes a vast array of text sources. This figure shows how Gopher compares to other state-of-the-art models on various language modeling benchmarks. Clearly, Gopher exhibits substantial performance improvements, particularly on tasks involving books and articles. Scaling language models isn't without its challenges. The researchers did an extensive analysis of how model scale impacts bias and toxicity. They found that larger models are more likely to generate toxic responses when given toxic prompts, but are also better at classifying toxic text. This dual nature presents challenges and opportunities for improving AI safety. In this panel, you can see how the toxicity of generated text varies with model size. Larger models tend to produce more toxic responses when prompted with toxic inputs, which suggests scale has a nuanced impact on model behavior. The team explored using Gopher for dialogue by prompting the model with a specific conversational format. Although the model could engage in conversation, it sometimes produced factual errors and highly confident yet incorrect responses. The authors emphasize the need for future work to focus on more efficient architectures. They also address the importance of applying downstream mitigations to tackle bias and toxicity. The long-term goal is to create models that can understand and follow human discussions while ensuring safety. That's a wrap on this deep dive into the Gopher model. For more details, you can check out the full paper linked below. If you found this summary helpful, don't forget to like and subscribe for more research summaries on Arxflix. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.